Hi, my name is Gabriel and I'm the team leader of SKYGUARD. And our goal from the very beginning was to find a method of preventing bird strikes in aviation. Every year it's estimated that there are over 20,000 bird strikes, with there being many more going unreported. That's 50 to 60 strikes a day and about $1.6 billion worth of damages done to aircraft per year. Bird strikes can also be very dangerous, with there always being the possibility of damage to onboard systems such as the landing gear. Here at SKYGUARD, we tried and researched many different ways to prevent this, but in the end we settled on utilizing the power of sound and frequency. Over to you, Rishad.
Hi, my name is Rishad and I'm the lead designer here at SKYGUARD. What the team and I have created is a sonic device known as a SKYGUARD Sonic. Here at the front, it emits a high frequency that is capable of deterring birds while having a quite high quality camera that is able to detect them efficiently. The dimensions of the Rhino model, as we can see here, are 702mm while having a 600mm diameter. The interior is comprised of a DC power supply, DC to AC converter, and an amplifier, which meet the requirements for the 7 transducers in series with the rest of the components. The transducers are 1 to 2 kHz, which is within the bird hearing range, and these frequencies will be amplified to high decibels to deter the birds. As we can see, there are hinges on the transducers, which are equidistant from themselves and from the center, which allow it to face more outwards or inwards to the center, which is determined by the distance of the birds. As we can see for the outside, it will be mainly comprised of this area of carbon fiber. However, I've used a more metallic texture for presentation purposes, while this area will be comprised of a polymer, which is elastic and hard wearing in order to be flexible but not let any air gaps in. The top part has 4 corners which have screw holes, allowing it to be attached to the bottom of the wing while being near the engine. It also has a large surface, allowing for an adhesive to be applied, while extra rubber circles which allow for extra friction. And as we can see, there is a stand for the camera, which is dead center in the plate.
Hi, I'm Jacoby Glass and I'll be explaining the detection module of the SKYGUARD Sonic. Here we have an overview of the architecture. You can see the camera feeds connected up to the single board computer, which is pretty powerful as it's doing most of the heavy computation, where it's detecting the bird with computer vision and sending that pixel data to an angle calculator, where it can spit out yaw and pitch values for the gimbal. The SBC also contains a statistics module, which is able to track each use and provide us with analytics such as the time it was used, the altitude and the position, as well as the plane type and model. The first part of the system is the lens distortion correction, and that's going to be using OpenCV technology to undistort the image and get rid of any inaccuracies. The bulk of the system is the bird detection model, which is what's actually locating the birds on the screen. We won't be using a more classical RCNN model since it's too slow to deal with the constant video output. Instead, we'll be using something like YOLO, which is more quick and lightweight, and we can use that with a dataset to train up a working model. The last step is the angle calculator, which is going to take the central pixels of the bounding box outputted by the AI and use the camera's FOV and image resolution to calculate yaw and pitch values required to aim at the target. Here you can see my implementation using time approximation, which accounts for the geometric distortion from the high FOVs we'll be using. And once these more accurate angles are calculated, they can be sent off to the gimbals, readying the system for the next step.
Hi, my name is Nat and I'll be talking about the market. For each unit, production costs are between £4,000 to £5,000. We sell each unit for £16,000 and we provide an optional tiered subscription, which includes software updates and maintenance costs for £110 or £400. This all gives us about a 220% gross profit margin. By simulating realistic sales in an ideal scenario, we can project a revenue upwards of £260 million in 10 years. By selling 7,500 units and retaining an ideal subscription retention rate, we could end up having a market penetration rate of 0.35% over the 10 years.
We believe that if our product is implemented widely, we could reduce the number of bird strikes per year by at least 90%. Thank you all for listening, and we are SKYGUARD, creating safer skies, one flight at a time.